Welcome to Module 2 of the e-learning course on Smart City. This module will introduce major technologies and services of a smart city. Smart City is a platform where various innovative technologies are implemented and combined into an urban infrastructure. So, in this module, we will talk about the necessity to establish a smart city, development phases of a smart city, and finally, the future trend of smart city technologies. By the end of this module, participants will be able to describe Smart City as a platform and define the related services, explain representative smart city technologies and solutions, infrastructure, data, and service, and specify how to apply smart city services to your own country or city as an urban problem-solving solution. First, we will look at what a smart city is. Then we will look at the development phases of a smart city and the necessary technologies and services. Finally, we will talk about the future trend of smart city technologies. First of all, we will introduce smart city in the perspective of technologies. Why is a smart city important? According to the ITU project officer Reina Ubeda, we live in a world of cities, and our planet is increasingly urban. Cities are the new engines of growth in the global economy, responsible for 80% of global GDP. Utilizing ICT such as AI, big data, 5G, etc., the city is rapidly emerging as an innovative growth engine. Therefore, the city will act as a platform which connects people, space, and things. According to the ISO international standard, the smart city operating model has different characteristics compared to the traditional city operating model. First, the traditional city operating model is unconnected. Individual citizens or businesses have had to engage separately with each silo, making connections for themselves rather than receiving seamless and connected services that meet their needs. Therefore, data and information have typically been locked within these silos, limiting the potential for collaborations and innovations across the city and limiting the potential to drive citywide changes at speed. The key feature of a smart city operating model is that its digital assets, data, is available in real time and on an open and interoperable basis. Citizens, SMEs, and social entrepreneurs enables to co-create bi-directional public services and create new values by making use of city data. The Smart City operating model enables externally driven and community-led innovations by citizens, businesses, and civil societies by opening up city data and services. It also facilitates internally driven, city-led innovation to deliver citizen-centric and sustainable services. In this sense, it establishes citywide governance and stakeholder management processes to support and evaluate these changes. It provides citizens and businesses with public services which are accessible in one over multiple channels. The operating model also involves citizens, businesses, and communities directly in the creation of user needs. For the second chapter, we will explore the development of Smart City. The discussion on smart cities has become an emerging topic for both developed countries and developing countries. And the concept definitions of each country greatly varies depending on each contextual circumstances. In recent years, a number of definitions describe a smart city as a means or a platform, and the majority of the definitions describe smart cities as enhancing the quality of life and city competitiveness by making city functions more efficient by utilizing ICT. The components that make up a smart city are largely divided into infrastructure, data, and services. Also, there are lots of smart city infrastructure and data-based services, such as smart safety facility management, smart mobility, smart grid energy management system, EMS, smart environment, smart welfare, digital economy. The development phase components that make up a smart city are largely divided into 1. Infrastructure, 2. Data, and 3. Services, and are composed of 5 sublayers. The infrastructure component includes physical and technological infrastructure, including city, ICT technology, and geospatial information infrastructure. The data component comprises both 1. Sharing, and 2. Using data for free on all infrastructures and objects in the city based on IoT technologies. There are 2 major steps. First, a vertical construction is required, which consists of individual function and service intelligence. Second, a horizontal construction is implemented to build a common open platform for the related functions and tasks, constituting the convergence intelligence component. The service component is the last development stage of a smart city. By looking into the different development phases of a city, one can deduct that the cities share information like organisms. We can also expect the future city beyond smart cities, forming the stage of urban transformation. The infrastructure phase is composed of 1. City infra, 2. ICT infra, and 3. Geospatial information infra. City infra focuses on the urban hardware, such as constructing buildings. Smart city infrastructure is usually software, such as ICT, but it needs urban hardware to be developed. ICT infra is wired and wireless communication infra that can connect an entire city. Geospatial information infra is majorly used for convergence of real space and cyberspace. It consists of map information, 3D map, location-based services, GPS, satellite imageries, etc. Secondly, the data phase is composed of IoT and data sharing. IoT is mainly used for information collection by making use of various sensors. It is applied to a number of areas, consisting smart cities for diverse sectors such as transportation, energy, and safety, etc. Data sharing, hence, freely supports sharing and utilization of produced data. Lastly, the service phase is composed of 1. Algorithm and service, and 2. City innovation. Algorithm and service is a crucial factor to increase the ability to utilize data, such as data processing and analysis. And there are various communities conducting pilot projects like Living Lab. In addition, city innovation is a term used to comprise institutions and social environments that enables ideas and new services to solve urban problems. ICT technologies used in smart cities include 24-hour monitoring, sharing real-time information, ubiquitous controlling, which can increase efficiency, productivity, transparency, and competitiveness, bringing effects such as decrease of pollution, crime, and vulnerability. These can be applied to various sectors such as environment, mobility, living, energy, etc. You can see the representative of smart city technologies. Representative technologies are displayed for each respective development phase of a smart city. In the infra phase, number 1, 5G, or 3 or 4G, 2, IoT, 3, WLAN, etc. are representative technologies. In the data phase, number 1, big data, number 2, AI, number 3, blockchain, and number 4, security, etc. are the representative ones. The service phase contains a number of different areas such as life, governance, autonomous vehicles, energy, etc. The extent in which different areas can be included is continuously expandable. One of the main infrastructure technologies is wireless technology. The smart city growth is expected to be accelerated by the next generation wireless. Each country faces different circumstances, but 5G technology will meet common growing demands of smart cities, including more connections, a quicker and more adaptive response time, such as time-sensitive applications, vehicle-to-vehicle communications, and ultra-low power connections that includes sensors for leak detection in water mains. IoT is the most important technology for the infraphase. IoT ensures that everything is provided with a unique identity and is equipped with the ability to automatically transfer data over network without human-to-human or human-to-computer interactions. Everything is connected over IP, and home appliances, parking lots availability, traffic congestions, and emergency situations are controlled in real time. It can also be used to increase social value by implementing safety and environmental monitoring and increasing public goods such as electricity and water management at the national level. Let's look at some more IoT use cases. 4 main use cases are described, including 1. Surveillance, 2. Connected traffic signals, 3. Parking, and 4. Lighting. First, by using IoT-based CCTV functionality, crime detection and resolution can be improved, and city management can be ameliorated. Also, IoT connection between vehicles and facilities can reduce the traffic congestion and lower the fuel usage. Also, enhances the improvement of the emergency services response times. With efficient parking space management, it becomes possible to reduce fuel and cost of cars and ultimately to reduce environmental pollution. Lastly, smart lighting can be adjusted autonomously according to the surrounding environment and circumstances that increases efficiency and reduces management costs. This ultimately results in power and cost savings, engendering the reduction of environmental pollutions. These are more use cases related to IoT. We would suggest you consider the problems and improvements your country faces and how different stakeholders tackle them using IoT technology. Air, traffic, waste, water detection, athletes checks, building monitoring, vehicle detection, energy usage monitoring, machine monitoring, etc. Big data are large volumes of rich data, structured, unstructured data, sensor data, audio, video. Big data have 3 characteristics. We can call them 3V: volume, velocity, variety. From the volume feature, big data are too large for traditional DB and analysis tools. Therefore, they require a distributed approach with a parallel SW running on large numbers of servers. From the velocity feature, big data are rapidly changing data, such as a stream of online sales transactions or real-time data of clicking behavior on websites. From the variety feature, big data are heterogeneous contents, which are assembled from multiple sources. These are structured, unstructured data, sensor data, audio-video data, and all kinds of data, etc. Due to the diversity of the size and characteristics of data produced in real time, the speed of processing became an essential factor to produce big data. In recent years, properties such as veracity, variability, value, and visualization have been added. The advanced analytical technology enabled to find patterns and correlations in countless types of data and permitted to extract statistical techniques. It also helped to enhance a variety of other applications such as outlier detection, clustering, pattern recognition, and link analysis, etc. Additionally, visualization techniques extended beyond traditional graphs and charts with interactive features. For instance, fine-grained sensor data of a city can be visualized as an overlay or geographical maps to be easily interpreted by humans. By making use of the data visualization techniques, data management and analysis became possible, and many data analysis-related concerns were resolved. Finally, as many business communities, such as startups, use big data to create new business models, The future trend of big data is likely to continue to persist and be further developed. So far, we have described smart city technologies, and we will start introducing smart city services. Artificial intelligence, AI, is machine-based intelligent decision-making technology. AI combines machine learning with the ability to interact via natural language and create insight from massive amounts of data. AI system is a set of tools to emulate human intelligence by learning through data collection, exercising, and engaging through data analysis, decisions, and actions. AI technology will cooperate with IoT and big data. The data process flow is likely to be IoT, including sensors to record task statistics with blockchain solutions, is greater than big data, capability to store large volume of data, and greater than AI, for decision makers and for the selection of best case scenarios. AI don't need a defined algorithm, they create it from a huge amount of data. Classical software relies on rigid algorithms to create an output data with input data. On the other hand, AI software feeds both input and output data to generate algorithms upon which they learn to predict future outposts. A mailbot that automatically learns how to respond to client emails by reviewing past human-sent emails is an example. Smart cities develop various training datasets for machine learning and AI. One of them is the image annotation type data, which is very effective in detecting various things and analyzing them for a smart city. Some examples of the image annotation are: number 1, smart city security and surveillance; number 2, smart vehicle parking managements; and number 3, drone-based aerial view monitoring. Blockchain is a decentralized ledger of all transactions across a peer-to-peer network. Blockchain is a distributed system in which each node has a copy of the file in which transactions are logged, and cryptography is used to prevent entries in the blockchain from being altered. Using this technology, participants can confirm transactions without the need for a central certifying authority. There are lots of blockchain use cases in the construction of a smart city. Rewarding citizens for smart decisions. Cities can instigate the citizens to make better decisions for the environment. Cities can automatically give a reward for environmentally conscious behaviors. Universal ID cards. Identity information that could be stored securely using cryptography. Land, property, and housing management. An easily accessible record of land and property usage rights would be extremely helpful for citizens and governments alike. Interoperability for smart devices. The blockchain represents a single platform upon which smart individuals or companies will create a secure, interoperable controlled system for the massive and growing web of smart devices. Improving public transport. The blockchain can be a single point of payment for the various types of public transport. Energy, water, and pollution management. Renewable energy, water usage, pollution mitigation-related data could be stored on an interoperable, regularly updated record that helps the city make better decision-makings, or energy market. Prioritizing local commerce. Blockchain-powered marketplace and platforms have the potential to challenge and to help to tip the scales in favor of local businesses. Security for IoT devices. Blockchain's decentralized approach would eliminate single points of failure. Universal data storage platforms. All the data collected and interlinked in smart cities has to be stored in a decentralized data hub. Departmental transparency. Thanks to a single source of secure, verified information, it became possible to eliminate much of the confusion and misinformation. urban planning, through secure, easily accessible voting systems pertaining to urban and regional planning decisions. Keyless signature interface. Blockchain protects e-service like ID cards, e-health record, e-law, and e-court systems. Smart city platforms serve as a basis to unify data and information from many solid systems. The platforms provide a common mechanism for visualizing and managing data and optimizing the overall city operations. These can provide seamless access to data across multiple systems and operating domains to create a unified and holistic view of the overall performance. So far, we have described smart city technologies like infrastructure and data, and we will start introducing smart city services. Smart city services are implemented in many ways like smart transportation, smart energy, smart environment, smart living, smart governance, etc. There are many applications in smart city transportation systems, including cooperative awareness, safe lane changing, safe intersection crossing, optimal traffic signal control, emergency warning notifications, smart parking allocation, etc. Communications in Intelligent Transportation System, ITS, relies on two main modes, namely vehicle-to-vehicle, V2V, and vehicle-to-infrastructure, V2I. What would it take for an autonomous vehicle to run well? To do this, the car and the surrounding cars need to be connected and connected to smart city infrastructure such as roads. This is because autonomous vehicles can communicate with surrounding cars constantly and prepare for unexpected situations such as traffic accidents or fog that occurred several kilometers ahead through smart roads rather than judging and driving in all situations. The vehicle driving technology system that connects to all around is called V2X. V2X stands for Vehicle to Everything, which is a technology that allows the vehicle to exchange and share information with roads, transportation facilities, and other vehicles while driving. With the growth of autonomous vehicles, the growing need for a variety of electronic equipment provides a great opportunity for material parts makers, included in the traditional semiconductor and display industry structures. In addition, with the revitalization of the vehicle sharing market and autonomous vehicles, 24-hour delivery was made possible, bringing about an increase in logistics volume in the near future. By leveraging next-generation wireless technology, communications can improve transportation systems, enhance public transportation, and reduce traffic congestion and environmental pollutions. V2V communications could reduce the emerging traffic congestions by maintaining the safe distance between vehicles. It is also expected to bring other positive effects, such as the reduction of the environmental pollution. There are a number of smart transportation cases around the world. As one of Smart Transportation Solutions, ETC, electronic toll collection, was implemented in Vietnam. The tunnel management implemented in Norway can monitor the status of the tunnel's traffic in real-time traffic via the Internet. Highways management reduces congestions and takes the pressure off smaller roads in town centers that might get overwhelmed by traffic and pollution. Smart Parking System can show available parking spots near your destination with a scheme that shows the best way to park and the cheapest or closest parking areas. Smart Energy aims at green energy generation and energy consumption lowering. Also, it aims at energy consumption pattern by flattening peaks and providing resilient distribution grid. An intelligent home energy management system allows residents and suppliers to share commands to maximize their power consumption. This kind of partnership between the owners of energy lowers the power charges of customers and better controls renewable energy peak charges. Renewable energy-based technology that can both produce and consume energy is becoming popular. Renewable energy, such as solar and wind energy, is used to disperse and renew energy, and smart grids that enable individual energy management are in the spotlight. Smart metering is a device that manages energy consumption of consumers in real time while seeking to save energy consumption. EMS is the Energy Management System. Energy management software introduced in energy-intensive buildings, factories, and home areas where energy management is considered important is called the BMS, buildings, FMS, factory, and HEMS, home, respectively. In addition to smart meters, platform technologies are needed in smart grid environments to link renewable power generation, such as solar and wind power, and to manage energy management, such as energy storage systems and electric vehicle batteries. Smart environment is a connected world where sensor-enabled connected devices work collaboratively to make the lives of dwellers comfortable. The work on IoT-based smart environments can generally be classified into the following areas: A. Smart cities, B. Smart homes, C. Smart grid, D. Smart buildings, E. Smart transportation, F. Smart health, and G. Smart industry. Water will be one of the 21st century's biggest urban challenges. Smart water solutions aim at minimizing waste and securing quality as one of the pillars of sustainability. Waste containers with sensors that detect the volume of the waste will be used to optimize the collection of them. Also, the introduction of an automated recycling system will improve citizens' living conditions and improve their efficiency. Pollution monitoring systems such as air, land, and smell will contribute to the improvement of the environment. We can lead a smart living through a smart city. Smart education will focus on digitalization and personalization and pursue the lifelong learning. Smart health can measure self-health, and consumers can judge with great authority over medical information through big data. Smart technologies that permeate the surroundings enhance citizen safety. These are smart street lighting, drones for risk assessment, smart police, and smart surveillance robots. Smart home is operated by smart devices and appliances with sensors to monitor. It seeks to home automation with intelligent information and feedback. All citizens can simply ask and vote through the mobile voting app. A participatory voting app is an app where everyone can ask questions, whether on policy or on any real-life related issues, or simply vote on it. With either a smartphone or a PC, a secret vote targeting specific people or a voting targeting citizens in a specific location is available. Smart government will use the disruptive potential of technology and data to innovate in all parts of the value chain. Government analyzes social problems with big data and advanced analytics. And policymaking will become more effective due to relevant feedbacks and creative alternatives. Government will define the high-level requirements and execute policies using digital platforms and mobile apps. A series of policy processes are implemented on a data basis which aim to strengthen existing and planned policies. For the third chapter, we will explore the future of smart city technologies. Gartner, a globally recognized company, forecast the development of IT technology through the annual Hype Cycle announcement. In Hype Cycle 2019, Gartner saw the city as an important platform for future technology and data for good, civic and community development, micromobility, 5G, chatbots, transportation strategy, water management, and blockchain are expected to emerge within the next 5 years. Smart building, blockchain-based business models, data marketplace, IoT platform, etc., will require more than 10 years of research and development. Obsolete before plateau. That is, the innovation will never reach the plateau, as it will fail in the market or be overtaken by competing solutions. Technologies that are categorized as transformational and high in the priority matrix include, but are not limited to, distributed generation and smart lighting. Both aid in spotting and solving urban issues such as traffic congestion. Within the next decade, data marketplace, blockchain business models, and city operation centers are anticipated to be the transformational priorities with a huge impact on socio-demographic and ecosystem development. IoT platforms and IoT-related priorities are becoming more mature and will, therefore, have a faster benefit realization in smart cities. Standardization is in progress by a number of global standards organizations, such as ITU, ISO, IEC, ETSI, and IEEE for smart city-related technologies, common technology, infra, data, services, etc.